Hey everybody, this is Larry. This is day 7 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. My calendar 3 is a hard problem. It's a Thursday evening or Friday morning, depending on where you are, but it's a Thursday evening here, so let's hope I make it through so I could go to the gym afterwards. Okay, 7:32, my calendar 3, hard problem. A K booking happens when K events have some non-empty intersections. If there's some time that is common to all K events. K events have some non. So I'm just pausing this because I feel like these aren't quite the same. K events have non. Oh, okay. Actually, no. Maybe that makes sense. If you're thinking about, I was thinking about pairwise intersection, but I guess if you intersect everything, okay, fine. You're given events start and end. Close bracket on the end. After each given event, return an integer k representing the maximum k booking between all previous events. Okay. Maximum k booking. So it's okay. Huh. Okay. So I would say, first of all, if this problem wasn't live, and what I mean by live is that you have these queries that you're supposed to answer every time, it's a very straightforward sweep line problem, right? You sort by start or something like this, and then you just like go from left to right, and then you count up the max, right? This one may be a little bit trickier. Let's take a look at the constraints. So 10 to the 9 means that you can't do something as simple as like a boolean array, as much as we wish for that to happen. But at most 400 cores, right? What does that mean? Well, what that means is well, there's something that happens with these live events, right? The first thing to notice is that book can only return. So the answer is always either the last answer or the last answer plus 1, right? So, and of course, the only change is from the booking the last interval, right? So that means that we only have to care about the last. So I would do something like this. Oops. And like self dot. I don't know. Well, that's the thing. But then now I'm trying to think, right? So given a thing, we are basically asked to count how many things did it intersect with. And of course, if you do it naively, it'll be n squared, which actually, I forgot that. I think I got that 10 to the 9 stuck in my head. If they're only at most 400k cores, then even if you do n squared, that's just 400 squared, right? So let's do that. And that should be fine. That's even less than 1,000. So, okay. So, yeah. So previous. Yeah, I mean, yeah. So then here we go, okay. Count is equal to 0. We're going to do it naively. I mean, I know that made some observation earlier. Technically, I guess you don't need it for this problem, but these are things that I'm thinking about. And I want you to, just think about these things just in general, because sometimes people call it pattern matching, but these are just the things that allow you to kind of build toward a solution, right? These are the Legos, the building blocks that I like to use. So, yeah, okay. So then now we just literally do like for S1, S2 in self.previous. Then we do, how does that go? N is non-inclusive, right? Or how does that? I always, because these are intervals, right? So like the exclusion just means that exactly the same is not or whatever, but I don't know. We'll see how that goes. Okay, let's just do n subtract 1. I like it inclusive, but this may be wrong, but I'm just, but I am mindful of it, right? But because technically it, it's that thing but over, right? So I don't know. We'll see. Okay, but yeah, but if S1 or S1 I think this is oops. I think this encapsulates every case. I hope I'm not wrong. And this is just from gut feeling experience. Yeah. Then we count increment by 1, right? So I guess we don't even like, sub that max is equal to max. So we definitely do not use the fact that this is monotonically increasing, but still. Okay, so this is already wrong. Oh, I forgot to append. Whoops. Yeah, after you do the counting, then we can append. So obviously, if you compare it to nothing, that's going to happen. And of course, keeping in mind that we already subtracted by 1. It's like, why is it 0? Okay, still wrong, but you have to count itself. So actually, count as 1, right? Because or you could either say 0, 0 to 1, or just like put the previous before. Though technically, I guess it's not previous anymore. But okay, so this looks good. Doesn't mean I'm confident, but let's give it a submit because I'm lazy. I'm lazier than I am confident, but okay. Yeah, there's maybe an off by 1, and I'm actually off by a bit. Maybe, and the reason why I'm not confident is just this n by m over 1. So let's see, right? So you test it by itself. This is 1 as well. This overlaps. So 1, 2, 3, 4, 5. So yeah, this overlaps at. Yeah, I think I'm just having like some off by 1 things, but how do I want to do it though? Would that solve it enough? Oh snap! I didn't. Well, I guess this is wrong anyway. But oh man, I lost the case. I didn't think that would work actually, to be honest. But I was just like, in case I'm wrong about me being wrong. Wait, what? The new UI is actually annoying in that regard. They let you copy and paste, but it doesn't actually copy and paste, right? You have to do like this weird thing. Okay. So we have the wrong answer here. We have 4. Why is it 4? On the 6 elements. So 0, 1, 2, okay, fine. This one, right? Okay, let's actually draw it out real quick, just because I don't know, don't have visualization power. So 24, 40, then you have 43, 50, you have 27, 43. Oh, that's already like a red flag, right? Because they don't intersect. But this too may be wrong. Because in the sense that it may think that this is intersection. Is that true? No, it doesn't think that this is intersection. Otherwise, it would have just returned. Oh, I think I misunderstood. Well, I didn't misunderstood, but they don't intersect at the same point. So actually, this is just wrong. Wow. Okay. I mean, there's still another n-squared solution. It's just like building it up, right? But it's a little bit annoying, I guess. I mean, even n-squared log n is fast enough. And not gonna lie, I had a couple of drinks earlier, so man, wow, yeah. I think I confused myself. So what happened here was that I think I did a conversion in my head a little bit, and then I didn't realize it, to be honest. But I did do a conversion, and what I mean by that is that I was saying that, you know, for this new segment, I wanted to see where I intersect, and then because what I want is not this, not the number of pieces I intersect. I made a mistake on the switch. Is that I want to see at what spot am I maximally intersecting, right? Yeah. Actually, yeah, I think we can do this still in n-squared. I was trying to think whether I need to do an n log n, or n-squared log n in this case. But yeah, so we have collection.sorted list, right? I'm gonna look up something real quick. You can't see me, but I'm just trying to see sorted list iterate. Because if we want to see every item, is it still n log n or is it O of n? Right? That's what I want to see. So I'm googling right now. Hang on. Sorted key list. Huh. Wait, iterator. Okay, I see I range and I slice. I just don't know whether or what the complexity is. So I'm actually looking at the code right now. So this is what I'm looking at, in case you're wondering. I'm looking at literally the source code for sorted containers. Solve that. Well, that's how I do things, if you're curious. I want to say from this, it seems like it is linear. Let's see, sorted list, Python, iterate, complexity. Maybe that's a little better word for Googling. Iterate. Doesn't really say. Update is okay. I want to say this is O of n. Like if you have a sorted list and you just go from left to right, because it's log n to insert. I don't know the exact implementation score, so we'll just have to assume this a little bit. And you know, if it's wrong, then I apologize. But basically, the idea I have is that, yeah. But basically, yeah. So then now we have solve.previous. We want to first, basically, we want to insert, and this is the same thing as a sliding window type thing, right? Basically, we want to do, okay, let's just have this, we bisect left on exactly start, and let's say -1, so that we get something that matches exactly start. Basically, we want to find the case where start is in it, right? Exactly, not just a nearby. So, okay, index is equal to this. If self.previous of index, and of course, if index is less than length of self.previous, if this is, if the first element of this is start, then what we want to do is we want to increment. That's basically why we have here, right? Because we're basically trying to merge start one. You know, this is what we said about sweep line, is that we're basically inserting this thing, and then if it combines, then that's good, we combine. Of course, 400, we can actually maybe be a little bit lazy with n square log n, but I'm going to try a little bit with this n square approach. So okay, so then self.previous index, so p is equal for previous, and then, yeah, and then we have self.previous of dot remove p, and then self.previous dot add p of 0, p of 1 plus 1, right? Because we're incrementing. Otherwise, then we just insert a new one. So this is something like this. Start 1, right? Okay, so far so good. This is the start part. And then we do the same thing for the n. So we do exactly the same thing. Man, I want to take a nap. Right, same thing. I mean, there's probably some deduping of code we can do here, but same thing. And of course, except for that, instead of +1, we -1, right? And then else -1, right? You may even be able to do it without it, to be honest, but like we can just insert it and then just sweep from left to right. But you may run into some weird, maybe you still may run into some timing issues. Okay, let's Let's do that. Let's YOLO a little. Okay. Right. I'm gonna comment this out so that I can go back to it in case my YOLOing fails, instead of the true YOLO of deleting this. But what I'm gonna do is actually, okay, we don't need to cite it. What I want to do is actually yeah, we just add start +1 without add and -1, right? Yeah, I think here we don't actually, because it's exclusive, we don't need that one. And then now we just do basically for x delta in self.previous. Yeah, so then count as equal to 0, which we already have, and we're gonna move it down here real quick. And then yeah, we just do count wait, let me think about this for a second. No, this is right, because basically what I want to make sure is that we subtract before adding, and I think by the nature of sorting this is true. So yeah, so count delta and then just this thing all the way. And I think that's actually mostly it. Let me run it real quick just to make sure that this is mostly it and not my imagination. Of course it's not in collection, it's in sorted containers. So yeah. Yeah, this is a long video. Hope you enjoy it. This looks good for both cases. Let's give it a submit. Hopefully this is fast enough. If not, then whoops. Cool. 920-day streak. It's very slow apparently. 4.5 seconds, mostly due to laziness. I think if we've done this, maybe it's slightly faster, but it's not even that much faster. But yeah, but let's go over this code real quickly. Now I can remove this. At least it's fat. It's short, even though it took me a long time to run it. But basically, what we're doing is just we adding, and this is the sweep line algorithm. Even though it may not look like it. Basically, we're adding the beginning at the end, and then we just sweep the entire thing to get the max overlap, and after we get the max overlap, we just return it. Yeah, that's all I have though for this one. I mean, we could do a little bit of we could do a little bit of visualization. Sorry about that. I'm just playing around. But yeah, we could do a little bit. I need to move this so that it's not really blocking my face. It's okay. But yeah, so you have a timeline or a number line, and then you're basically saying, okay, +1, -1, right? And then you keep on doing it in random places that they give you. And then if you go from left to right, you will basically go, okay, this is +1, so then this is 2, and then this is -1, -1, right? And this basically corresponds to the longest step, and that's basically what we're doing here. I mean, I know that the code is very short, and it's tempting to think it's easy as a result, but there are a lot of foundations and bases for building that. And yeah, the sooner you accept that this is not, or like that, you need to kind of think about it deliberately. And to be frank, I messed up, right? I took 20 minutes about this one, because I don't know if that I would say I misread the question per se, because I don't think I misread the question, but I think I did like I said, I did a transformation in my head of the problem by accident, and then I just implemented it incorrectly. Can you do better? The short answer is yes. So this is n squared. You could definitely do an n log n. So in insertion, you basically break it up to left and right? So that's basically the way that I would do it. But I mean, I said I was lazy, so I could kind of do it faster. But even then, I kind of did it not that fast, so maybe it wasn't worth it. But bringing this up, the idea here is that basically for every new point, you go, okay, let's say I added +1 here, right? Well, and here we keep track. Is that true? Maybe I'm wrong on this one. Because this goes to 1. But you don't know that this is 1 until you do a sweep, so. Well, the only thing that updates is everything in the middle. So, but that's still going to be n square because there could be n elements in the middle, right? I mean, I think you could do it with some higher level power stuff. The one thing that comes into mind, of course, is segment tree. Didn't really bring it up because I really generally like to avoid it just because I think it doesn't come up on interviews. But I think in this case, let me think about it a little bit more whether this makes sense. I think what I would do is actually with a segment tree. Yeah, if you do have a segment tree, then you could answer, like when you update, you could get the max of all the components, and basically the idea, and this is part of the propagation, etc. But the idea is just getting the max of the things that you of the components that you process, and then you propagate up, and yeah, and max should make sense. I don't know how I feel about that. But yeah, let me know what you think. Let me show the code real quick. Let me know how you did it, and let me know what you think. Let me know if, excuse me, let me know if segment tree works. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later, and goodbye. Goodbye.